enough. I guess before we get into anything more technical, at a high level, what is Coreboot? Like, what does it actually do on your system? And I guess from there we can go into why someone might want to use it.
Right. So Coreboot is mostly just doing the hardware initialization part. Before Intel Skylake rolled around, where they introduced so-called Intel FSP, it's most of the hardware initialization was mostly done in Coreboot. Like up to, I think, even recently, one of my colleagues, Angel Pons, reverse. I think they might have reverse engineered it. I'm not sure. But basically everything except for memory initialization, which was done in as a blob, was open. So now, because of the complexity of x86 systems, mostly, although it's also the case with ARM, which we'll get into later, like Intel and AMD provide you with so-called firmware support package, which is basically a very slimmed down version of EDK2 platforms that you can only get under very strict NDA. So Coreboot is basically loading FSP, and which is doing the hardware initialization, and Coreboot is telling it to configure, let's say, hey, you should set this parameter, like let's say this amount of VRAM, or you should set the memory controller to those settings or voltages. But basically, you almost never see Coreboot unless you hook up the serial output and enable debug, because when Coreboot is done with initialization the hardware, it passes control to so-called payload. So back in the day, we used CBIOS as a payload, which provide you with like BIOS calls, so you can boot like Windows, I don't know, XP or something. You also have Linux boot, which basically Linux kernel is used to initialize like frame buffer and so on. And like on Chromebooks or System 76 is using EDK2, very slimmed down version of EDK2 called UEFI payload. So when you, for instance, I know that you own one of the Chromebooks. So when you press the power button, when the screen comes on, that's not Coreboot at this point. That's already EDK2.
So there's there's one term you used in there that I probably should define for people. What is FSB?
FSP. It's so-called firmware support package. So you get
Okay. Yep.
Yeah. So you on some platforms it's 3 binaries, on some platforms it's 2, because Coreboot is doing like when Coreboot starts, it first needs to initialize the bare minimum in, I believe it was in CPU cache, then it needs to initialize the memory, and then everything else like I think interrupt controllers and whatnot. Of course, there are more to this depending on the system you're using, because let's say on Intel side of things for now to make it simple to understand. So when Coreboot first starts, it starts loading either FSP-T, which is temporary RAM initialization, and then it's calling, I believe, I actually forgot, so I will have to check. But I think first is FSP-M, which is initializing the memory controller. It's training the DRAM, and then it's initializing the like in secondary CPU cores and so on. It's FSP-S, which is FSP. Like FSP-T stands for FSP temporary RAM initialization, FSP-M, FSP memory initialization, and FSP-S silicon initialization. So that's how it's done on x86 currently. So because companies like Intel don't want to have their code they're using to initialize the platforms publicly available, they just give you the binaries that are, you can find them on their GitHub, not for every CPU family, but for most of them.
Mhm.
And you can basically control them via the API.
Mhm. So when we look at a regular system, like you just buy some motherboard, just whatever it is. So
Mhm.
this is using a standard UEFI, and my understanding is Coreboot is sort of taking the place of that system.
Exactly.
Mhm.
So when you buy a mainboard or laptop these days, it will come with firmware from one of two companies.
Mhm.
One of them is American Megatrend, and the another one is Inside H2O.
Mhm.
From what I know, both companies are getting so-called platform reference code. Sometimes it's FSP, sometimes it differs.
Mhm.
But basically, they get like a EDK2 from vendor like Intel or AMD, and then they add their own modules for like when you go into EFI, when you get like a MSI or Gigabyte or Asus, different vendors,
Mhm.
they have their own setup programs. But under the hood, it's all just EDK2 basically.
Right. So they usually like brand it their own way, so it looks like their own thing, but under the hood, it's either one of these two companies.
Yes, exactly.
A fun example of this is that on the Steam Deck, they have a very I don't know why they've done it like this, but the UEFI they have is very minimally branded. So it's got like inside H2O like all over like all over it. But like if you go buy like a Gigabyte board or something like that, you anyone who's gone into the UEFI or on an older system on the BIOS would have seen the way they handle it in like their own, I guess, whatever skin they want to apply to it effectively.
Yes, so I think that two companies that I know from the top of my head using Inside H2O is Valve on the Steam Deck and also Framework.
Okay.
Yes. But from what I recognize, like all the major like mainboard vendors, all of them are using AMI.